Hello, in this lecture we will find the value of 2 times AP or the size of 2 times AP. In the picture we have triangle ABC. The size of AC side is 70 units. The size of CB is 50 units. Okay, the size of CB side is 50 units, and the size of AB side is 90 units. And we have also a circle with center. The center of the circle is point P, and side AC of the triangle is tangent to the circle in point that we will call that point E. Side AC of the triangle is tangent to the circle at point E. And also side CB of the triangle is tangent to the circle at the point, we will call that point O. Again, side CB or BC, it is the same. Side CB of the triangle is tangent to the circle at point O. First of all, we will connect points P and C by a straight line. And we also connect points P and E by a straight line. As you can see from the picture, PE is the radius of the circle because it the straight line exits from point P and touches the circle at point E. So it is defined as the radius of the circle. I will mark it as R. The same, in the same way we will connect points P and O by a straight line. And actually PO is also the radius of the circle. I will mark it as R because it starts from the straight line starts from the center of the circle, that is to say from point E, and ends at point O on the circle. So that is defined as the radius of the circle. So OP and EP are the radiuses of the circle. Okay. Now, actually we have a rule that if you have a circle and from external point of the circle, let's call that point V. point V is external point to the circle because point V doesn't exist inside the system, inside the circle, nor on the circle. So it is outside the circle. For that reason, point V is called point that is external for the circle, and actually from this external point of the circle, if you draw two tangents to the circle, this is the first tangent. Let's call the touching point of the tangent with the circle L, and also we will draw a second tangent to the circle and let's call the touching point of that tangent with the circle F. So the rule is that VF equals to VL. Okay, so if you draw from external point of a circle two tangents to the circle, then those two tangents are equal to each other. For that reason, VL is equal to VF. Okay, so actually that rule is correct for every circle. If you have an external point of a circle and you draw from that external point two tangents to the circle, then those two tangents are equal to each other. Okay, so actually we can implement this rule in our circle because point P is point that is external point of the circle, because it is not inside the circle nor on the circle, so it is considered an external point of the circle. And from point C we have two tangents to the circle, tangent CE and tangent CO. So according to the rule that I told you, we can deduce that CE equals to CO. Okay, we can say that CE equals to CO because you draw two tangents from external point, that is to say point C, to the circle, so those two tangents are equal to each other. For that reason, CE equals to CO. Okay? Okay, CE equals to CO. Okay, CE, that's tangent, equals to CO, equals to this tangent to the circle. And as I have already told you, PE is the radius of the circle, and PO is also the radius of the circle, so we can also say that PE equals to PO equals to the radius of the circle And also PC equals to itself. PC equals to PC. So CE equals to CO, here CE equals to CO, PE equals to PO, PE equals to PO, and PC equals to itself. Okay, so for that reason we can say that this triangle, the green triangle, has three sides that are equal to the black triangle. Three sides of the green triangle are equal to three sides of the black triangle. Because CE of the green triangle equals to CO of the black triangle, PE of the black triangle equals to PO of the black triangle, and PC of the green triangle is equal to PC of the black triangle. Okay? And from that equality we can deduce that the green triangle, that is to say triangle CEP, triangle CEP congruent to triangle COP. Okay, triangle CEP congruent to triangle COP. Or triangle CEP overlap triangle COP, the green triangle congruent to the black triangle. Okay? Again, for the reason that three sides of the green triangle are equal to three sides of the black triangle, we can say that the green triangle congruent or overlap the black triangle. Okay, and from that fact we actually can deduce that angle ECP of the green triangle, angle is ECP of the green triangle equals to angle OCP of the black triangle. Again, angle ECP of the black triangle equals to angle OCP of the black triangle according to the rule that corresponding angles in congruent triangles are equal to each other. I will repeat again. Angle ECP of the green triangle equals to angle OCP of the black triangle, because of the rule that corresponding angles in congruent triangles are equal to each other. So if we call to angle ECP theta, then angle OCP will be also theta. Okay, so we can say that angle ECP of the green triangle equals to theta equals to angle OCP of the black triangle that also equals to theta. Again, angle ECP of the green triangle equals to theta and also equals to angle OCP of the black triangle that also equals to theta. Okay, now I will draw triangle ABC again. So this is triangle ABC, and As you can see, AC is 70 units, BC is 50 units, and AB equals to, side AB equals to 90 units. And also we have CP, P is the center of the circle, and actually CP divides angle ACB of the triangle to two halves. This is the first half and this is the second half. So actually we can define CP as an angle bisector. Okay, I will write it. CP is actually an angle bisector because it divides angle ACB of the triangle to two halves. Okay, for that reason actually split angle ACB to two halves, and for that reason CP is called an angle bisector. Okay, CP is an angle bisector, and according to the angle bisector theorem, an angle bisector in a triangle divides the side that it eats in a ratio that equals to the ratio of the angles sides. I will repeat again on the angle bisector theorem, and then I will explain it in detail. The angle bisector theorem states that an angle bisector in a triangle divides the side that it eats in a ratio that equals to the ratio of the angle's sides. Okay, now I'll explain the theorem. An angle bisector, in our specific triangle, we have an angle bisector that is called PC. and I explained you why CP is an angle bisector, because of the fact that it splits angle ACB of the triangle to two halves. For that reason, CP called angle bisector. So an angle bisector CP in triangle ABC divides the side that it eats. CP, the angle bisector, eats side AB of the triangle, and it divides it to two parts, AP and PB. And the ratio between those two parts, that is to say AP over PB, equals to the ratio of the angle's sides. First of all, we relate to angle ACB that it divided to two halves by PC, the angle bisector, and angle ACB consists of two sides, side AC and side CB. And the ratio between those two sides is AC over CB. And that ratio equals to the ratio of AP over PB. Okay, so I will write it down. The ratio that PC, the angle, or CP, the angle bisector, divides side AB is AP over PB. Okay, CP, the angle bisector, eats side AB and divides it to two parts, to AP and PB, and the ratio between those two parts is AP over PB, and AP over PB equals to the ratio of the angle sides. As I've already told you, we relate to angle ACB, and ACB consists of two sides, side AC and side CB, and the ratio between the sides of the angle is AC over CB. And that ratio, AC over CB, equals to the ratio that CP divides angle AB. That is to say, to AP over PB. Okay, so the ratio that angle bisector CP divides side AB is AP over PB, and that ratio equals to the ratio of the angle sides, that is to say, to AC over CB, or AP over PB equals to AC over CB. Okay? So I will explain again. An angle bisector CP in triangle ABC divides the side that it eats, divides the side AB, because it eats side AB, so we relate to side AB, and when it eats side AB, it divides it to two parts, to part AP and part PB, and the ratio between those two parts is AP over PB, and this ratio, actually AP over PP, equals to the ratio of the angle's sides. We relate to angle ACB, and the ratio between the angle sides is AC over CB. So the ratio of AP over PB equals to the ratio of AC over CB. Okay, so the same ratio that angle CP divides side AB is actually the same ratio that is the ratio of the angle's sides. And the ratio of the angle sides is AC over CB equals to the ratio that angle bisector CP divides side AB. That is to say, it divides side AB in a ratio that equals to AP over PB. So AP over PB equals to the ratio of the angle sides, that is to say AC over CB. Okay? So, I'll repeat it the last time. An angle bisector CP in triangle ABC divides the side that it hits, that is to say divides side AB, in a ratio that equals to the ratio of the angle sides. And the ratio of the angle sides is AC over CB. That ratio is equals to the ratio that angle CP divides side AB, and CP divides side AB in a ratio that equals to AP over PB. That ratio equals to the angle sides, that is to say to AC over CB. So AP over PB, the ratio that angle bisector CP divides AP over PB, equals to the ratio of angle ABC sides, of angle ACB sides. And angle ABC sides ratio is AC over CB. So AC over CB equals to AP over PB. Okay, so now I will write the equation. I will mark the equation as equation 1. So equation 1 states that AP over PB equals to AC over CB, and actually if we define AP as X, then PB will be AB minus AP, that is to say 90 minus X, because AB is equal to 90, so 90 minus AP, that is X, equals to PB. So 90 minus X is PB. So I write it here that AP equals to X and PB equals to 90 minus X. Okay, AP equals to X according to our definition, and PB equals to 90 minus X. So actually we can replace AP by X and PB by 90 minus X. Okay, here I replaced AP by X and PB by 90 minus X. Now we know that AC equals to 70 and CB equals to 50. So I write it down. AC equals to 70 and CB equals to 50. So here we can replace AC by 70 and CB by 50. Okay, so I replaced AC by 70 and CB by 50. Now 70 equals to 7 times 10 and 50 equals to 5 times 10. I'll write it down. So we will replace here 70 by 7 times 10 and 50 by 5 times 10. Okay, I replace 70 by 7 times 10 and 50 by 5 times 10. Now we have 10 in the numerator and we have 10 also in the denominator, so we can cancel 10. We'll get that x over 90 minus x equals to 7 over 5. So after we cancel 10, we got that x over 90 minus x equals to 7 over 5. Now we'll multiply both sides of the equation by 5. So we multiply both sides of the equation by 5, so 7 divided by 5 times 5 equals to 7, and x over 90 minus 6 times 5 equals to 5x over 90 minus 6. Now we will multiply both sides of the equation by 90 minus 6. Actually, it is allowable to multiply both sides of the equation by 90 minus 6 because as you can see in the picture here, x is less than 90 because AB equals to 90 units and x equals to AP, and AP is less than AB that equals to 90, so AP that equals to x is less than 90 units, so 90 units minus x will be a positive number and it can never be 0, so we can multiply both sides of the equation by 90 minus x. So after we multiply both sides of the equation by 90 minus 6, we got that 7 5 times x over 9 divided by 90 minus 6 times 90 minus 6 equals to 5x, and 7 times 90 minus 6 equals to 7 times 90 minus 6. So now we will open the brackets here. We will get that 5x equals to 630 minus 7x so we open the bracket. 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x. Here we will add 7x to both sides of the equation. So to 12x. So after we added 7x to both sides of the equation, we got that 630 minus 7x plus 7x equals to 630, and 5x plus 7x equals to 12x. Now we'll divide both sides of the equation by 6. So after we divide both sides of the equation by 6, we got that 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. And we have 2x equals to 105, but we also defined that AP equals 2x, so we write it down. So AP equals 2x, so 2 times AP equals to 2x. So here we have 2x equals to 105 and 2x equals to 2AP, so we can write it in the first equation that 2x equals to 105 also equals to 2AP. We write it together in the first equation. 2x equals to 105 equals to 2 times AP. So we wrote together the 2x is equals to 105 and 2x also equals to 2AP. We wrote it together. So as you can see here, 2 times AP equals to 105, so we write it down. Okay, from here, copy it here, the 2AP equals to 105, and actually that is the answer to our question. The question was, what is the size of 2 times AP? And the answer is that 2 times AP equals to 105 units. I mean, and here 105 units. Okay, So 2 times AP equals to 105 units. Okay. So I will summarize the lecture. Actually, we wanted to find the size of 2 times AP, or the value of 2 times AP, and we have triangle ABC. We know the sides of ABC, and we also have circle and 2 tangents to the circle, and actually we have a rule that if from external point of the circle you draw 2 tangents to the circle, then those 2 tangents are equal to each other. That's to say VF equals to VL. So we can implement this rule in our circle. We have an external point to the circle, and from C we draw 2 tangents to the circle, so those 2 tangents are equal to each other. So CE equals to CO, and also PO equals to PE because they are radiuses of the circle, and also CP equals to CP. So we have 3 sides of the green triangle that equals to 3 sides of the black triangle, and from that we can deduce that the green triangle can go end to the black triangle, and for that reason we can say that angle PCE equals to angle PCO, according to the rule that corresponding angles in congruent triangles are equal to each other. So if we call angle PCE theta, angle PCO will be also theta. So I draw again triangle ABC with PC that is actually angle bisector because it splits angle ACB to 2 halves. This is the first half and this is the second half. So PC is angle, it is angle bisector. So we have a rule that in a triangle, angle bisector in a triangle, in our case is triangle ABC. This angle bisector divides the side that it eats to 2 parts, side AP and side PB, or part AP and part PB, and the ratio between those 2 parts, that is to say AP over PB, equals to the ratio of the angle sides, and the ratio of the angle sides is AC over CB. So AP over PB equals to AC over CB. So we relate to the angle ACB that this angle actually is split to 2 equal parts by angle bisector PC, and actually the ratio between angle bisector ACB consists of 2 parts, side AC and side CB, and the ratio between those 2 parts, that is to say AC over CB, equals to the ratio that angle bisector PC divides side AB, that is to say AP over PB, or AP over PB equals to AC over CB. So we define AP equals to X, so PB equals to 90 minus X, and we know that AC equals to 70 units and BC equals to 50 units. So according to all the data that we have, we got the final answer that 2 times AP equals to 105 units. Okay, 2 times AP equals to 105 units. Okay, thank you very much.